The purpose of doing our demonstration is to understand the importance of the mole in chemistry. In order to do chemical reactions, we have to understand the importance of the mole. In this chemical reaction, we're reacting hydrogen gas and oxygen gas to produce water. Hydrogen gas and oxygen gas are dangerous chemicals, and we don't store them because they're expensive and dangerous to store. So in order to do this reaction, we actually have to make the reactants on site by doing other chemical reactions. And by doing this, we can learn how important it is to understand the mole in chemistry. In order to make oxygen gas, we have to do a reaction using a chemical called potassium chlorate. When we heat it, it makes oxygen gas and a salt called potassium chloride. In making a hydrogen gas, we do a reaction with zinc and hydrochloric acid, which makes the hydrogen gas in a chemical called zinc chloride. The question we want to ask ourselves is, how many grams of each substance do we need to make the right amount of oxygen and hydrogen gas that we're supposed to have to do this reaction? We want to fill the glove with the right amount of gas. How much gas do we need? And how does that tell us how many grams do we need? These are the processes that we have to do in chemistry in order to do chemistry properly to get the right amounts that we need. This is why we learned about counting atoms and atomic mass and the mole. The following clips are going to help us work through and understand this process just a little bit to make the connections to see how important the mole is in determining the quantities needed in order to perform chemical reactions the proper way. Here we have the hydrogen-oxygen reaction generator that I designed. It's specifically designed to produce hydrogen and oxygen gas for the specific reaction between the two gases. The point at which the glove is attached is called the production outlet. It's a piece of glassware called a drying tube. It's filled with a drying agent to absorb any water vapor that's produced from the reaction that creates the hydrogen gas. This component is called the bubbler. The piece of glassware is called an evaporator trap. It's filled with distilled or deionized water. It also helps capture water vapor from the reaction that produces the hydrogen gas, and it also helps us monitor the amount of hydrogen gas being produced by watching the bubbles that are formed. This is the hydrogen generator. It's made of two components called a separatory funnel on top and a vacuum flask on the bottom. The separatory funnel is filled with the 12 molar hydrochloric acid, and the vacuum flask is filled with the zinc. A valve called a stopcock is released, which allows the hydrochloric acid to flow down into the zinc, creating the reaction. The reaction can be carefully controlled by adjusting the stopcock valve. This is the oxygen generator. It's composed of a vacuum flask and electric hot plate. Potassium perchlorate is mixed with a catalyst called manganese dioxide. The heat performs a decomposition reaction which rapidly produces oxygen gas. This is the first reaction that's performed since the gas is produced so rapidly. The last component is the Y adapter, which allows the gases to mix from the two reactions, going to the gas outlet and mixing into the glove. Here I'm performing the calculations to calculate the exact number of moles of gas in the right proportions. I want to get the number just right so that I fill up the glove to the exact amount so that I can get the best explosion possible without popping the glove. Do you notice what's so critical in all these calculations? Here I'm using the moles of gas from oxygen to calculate the moles and then grams of potassium chlorate I need. I need 12.2 grams of potassium chlorate. Here I'm calculating the grams of zinc I need from the moles of hydrogen gas that I've calculated before. Here I'm calculating the milliliters of hydrochloric acid I need. Notice what's so critical? We have to watch it again. Respect the chemistry. What we should have noticed was when doing all those calculations that were necessary to get the proper amounts of substances to get the proper amount of oxygen and hydrogen into the balloon or the glove, was that we needed to use the mole in all of our dimensional analysis calculations. The mole was necessary to convert from atoms of hydrogen and oxygen to our moles of hydrogen and oxygen, which then allowed us to convert to our grams of our substances such as potassium chlorate and zinc, and then to our volume of hydrochloric acid we needed to react. We'll be doing more of this math later in a process called stoichiometry in another unit. But the basic understanding you need to have is that the mole is a fundamental understanding that we need to have and we need to understand in order to move forward to do some real chemistry.